Hello ladies and gentlemen, what's up? This is Papa Bale. Welcome to the channel. So currently I have hooked up my coil, which has 10 16 foot 20 gauge strands combined into 3 parallel circuits. Two of them have 3 strands and the other has 4. So circuit 1 and circuit 2 have 3 strands connected in series, and circuit 3 has 4 because there's 10. Just the way it worked out. Here we have a reed switch. Boom, right there. And it is connected. It's drawing any power that it needs from the collector of the first circuit, and it is connected into the base of all 3 circuits. And in addition to the circuit board, I now have a power distribution supply and supply that I can toggle each circuit on and off. So you turn the power on to your desired voltage, and then you hit the switch, and then that circuit is on, and the reed switch is when the reed switch functions. You're gonna turn all 3 of them on. We're gonna work with that. Should be pretty fun. All right. So at 1.7 volts right now. I'll turn the first one on. And we're getting some motion. Sweet. Let me just move it a little bit. Man, what? Huh, the light's not going on. Turn it up to 3 and just see if it'll function. There we go. So this is one circuit with 3 volts going through it. Alright, so now we're going to hit the second circuit. I'm going to leave the 3.2 volts going through. Now it's going through 2 circuits. Let me check the amp draw real quick. 0.2, 200 milliamps. Now we'll hit circuit 3. At 0.2, 0.1 amps. So much more like speed, RPMs increasing rapidly now. It's good to have it go slow because you can tell when it's actually like increasing at a reasonable rate. I think that's getting pretty there. Can't really see through this thing. Let me show you what I'm looking at. And then when I reach over to see what I can see, I end up moving the switch. So like 0.2. That's awesome. I think that's cool, man. That is so neat. Considering how I made this coil, it's like, it's all twisted up and everything. It's different than what I normally do. And this is just 3 volts in. It is a parallel circuit on 3 transistors. Alright, so I have an idea so I can stop holding it. I'm going to do that right now. Be right back. Alright, so I've now made all the changes that I was going to make. Let's fire it up, see what happens. I mean, if it's in the right position, this thing will start itself. So, but we are currently, let me get over here, at 6 volts, 6.6 in. I'm fluctuating on our amperage draw between 1.5 and looks like 1 or 8, something like that. But let's hit number 2, circuit number 2. That's awesome. Let's get the kinetic view. It's great. It's good. Just that one, it's axial flux, just that one coil right there. It's a different style coil that I've done now. It's more like a Litz wire. That's how I made it. I used that hook on the wall right there. And there was a hook on this adjacent wall. That's exactly 16 feet. And then I made 5 laps, so I went there and back 5 times, and then I cut it. They gave me 10 strands of 16 feet. Awesome. I put a 32 gauge strand in there too, so it's definitely that in there as well. Very cool, very cool. Let's see if we can turn it up at all. Get a 9-volt battery test. We're at 3 amps though, 2.7. No joke on the amp draw here. I think I can move that reed switch back though, and it'll reduce the amp draw. So I'm going to drop it down to like 5. I'm going to cut the circuit. And the amp draw goes all the way down when you turn the last one off and cut the power. Really cool, I think. Nice and simple. It's only like 30 turns of a coil right there, so. But like I said, it's 160 feet of 20 gauge and 32 gauge. But I got all the 32 gauge strands kind of wrapped around. They're all right there. And on the other side. So there's 10 of those too. All in this coil. So man, I'm thrilled. I'm always happy when I do it. When I do it, and I do it in my freaking head, man. It's all mine. Didn't have to look up anything to do it, really. But I will give Benefactor, him teaching me, doing the wire making for his coils, kind of inspired me on making this one. I'm pretty sure this one will spin the Neo ball without a problem. So in place of the reed switch, I would hook up a signal generator, and they would all pulse at the same time. It'd be awesome. It'd be literally cool. But like the benefit of having the parallel circuit and the switchboard over here, the power switchboard, I can turn off, transistor number 2 if I want. I can turn off transistor number 3. So 1 and 2 are the same, and 3 is a little bit larger, It's got one more strand in it than the other two. So that one you get more magnetic field, less of an amp draw than the other two. And it's on a maglev, so it's coasting nicely now. But yeah, let me turn it on real quick again. I might back that reed switch out for another video though. So turn it up to 9. We're pushing like 3 amps with just the one circuit at 9 volts. Alright, we've settled into like 1.8 to 2.4. It's still fluctuating pretty hard though. This is just the one circuit now. Alright, so I flipped that switch. Holy cow. And it went up to like 10 amps. I hope, oh man, there's no way. It feels like when that happens, the reed switch definitely gets closed. Like melted shut. So I gotta check it and see if it's broken. I know that the 2 are okay. So one of them is broken. Oh wow, that's awesome. See, this one is fried open. Number 1 is malfunctioning. And you can tell just because the reed switch is out of range and the amps still go up. So neat, man. So neat. But yeah, I'm going to switch that out and we're going to run this thing into the ground. Thank you very much. Peace out. Have a good day. Please subscribe. Bye now.